So we'll now conclude our study of quadratics by looking at quadratic inequalities. So before we looked at trying to solve quadratics, and we saw that we could do that with factoring and also with the quadratic formula. We're just going to replace the equal sign with a less than or equal, greater than or equal to, less than or greater than. It turns out the set of techniques is sort of independent of which of those symbols we look at. So here's a prototypical example. Ax squared plus bx plus c is greater than or equal to 0, but this could also be less than or equal, greater than, or less than. And the key principle we'll use to study this is the following, that if I have two numbers, capital A and capital B, and I multiply them together to get something greater than or equal to 0, there's two ways this could happen. A and B themselves could be greater than or equal to 0, or they could both be less than or equal to 0. So there's another way to do this, right? And this is following from the following observation that, positive times positive is positive, but also negative times negative is positive. So this observation will carry us very far with discussing when quadratics are greater than or equal to something or less than or equal to something. And the idea is simply to factor them and look at where the individual factors are positive and negative. So we can do something similar for less than or equal to. It's basically the same argument, which is that positive times negative is negative, and negative times positive is also negative. So what this suggests doing is that if I want to solve something like this, I should try to factor it and ask, when are these positive or negative? So essentially I can try to reduce my problem to linear inequalities and then look at when either both factors are positive or both factors are negative. So let's look at an example. Let's take x squared minus 1 greater than or equal to 0. So we want to know when this happens. So what we'll try to do is factor x squared minus 1 and see when either both factors are positive or both factors are negative. So I can factor this, I think, fairly simply as a difference of x plus 1 times x minus 1. So I ask, when is x plus 1 greater than or equal to 0? So that is when x is greater than or equal to minus 1. When is x minus 1 greater than or equal to 0? That's when x is greater than or equal to 1. So one way to get this inequality to be satisfied is if x is greater than or equal to minus 1 and x is greater than or equal to 1. Another way to do it is if x plus 1 is less than or equal to 0 and x minus 1 is less than or equal to 0. So this would tell us that x should be less than or equal to minus 1 and x should be less than or equal to 1. So I have x should be greater than or equal to minus 1 and greater than or equal to 1. This is equivalent to just asking x is greater than or equal to 1. And if I want x to be less than or equal to minus 1 and less than or equal to 1, this is equivalent to just x being less than or equal to minus 1. So my solution is x is less than or equal to minus 1, or x is greater than or equal to 1. Another way of writing this is I can go from minus infinity to minus 1, including minus 1, together with 1 to infinity. Right? This u here means or. So I can either be in the interval minus infinity to minus 1, which is corresponding to less than or equal to minus 1, or I can be in the interval 1 to infinity, which corresponds to x greater than or equal to 1. So we'll do another example like this. We'll look at x squared plus 5x plus 4 less than or equal to 0. So we'll factor this as x plus 1 times x plus 4 is less than or equal to 0. So I need either x plus 1 less than or equal to 0 and x plus 4 greater than or equal to 0, right? Because I want it to be less than or equal to. So this would give me x is less than or equal to minus 1 and x is greater than or equal to minus 4. Or I can have x plus 1 is greater than or equal to 0 and x plus 4 is less than or equal to 0. So this tells me x should be greater than or equal to minus 1 and x should be less than or equal to minus 4. So over here, if x is less than or equal to minus 1 and greater than or equal to minus 4, this gives me minus 4 to minus 1. But here, if x is greater than or equal to minus 1, it cannot also be less than or equal to minus 4. So this is impossible. So the only thing that can happen is minus 4 to minus 1, i.e. x is greater than or equal to minus 4, but less than or equal to minus 1. Right? And the reason that we have less than or equal to here and greater than or equal to here is because there's a less than or equal to there. So remember, I need positive times negative equals negative, and similarly negative times positive equals negative. So that's why we sort of had different conditions on the two factors here compared to the first problem. If I want less than or equal to, then I need one factor to be negative, one to be positive. If I want greater than or equal to, I need both positive or both negative. So you do have to keep this in mind, but that's really the only way that the problem is different, if you have less than or equal to or greater than or equal to.